Hi, everyone. As usual, we will be waiting 2 to 3 minutes before we get started, just to accommodate for the rest of the attendees who are still in the middle of connecting. Okay, welcome everyone. My name is Heike Ritter and I will be your host for this webinar. Thanks for joining and thanks for being part of our community. A few reminders before we start. This webinar is being recorded and it will be shared publicly. The recording will be posted on our community at aka.ms/security-webinars. During the webinar, please feel free to ask questions at any time by typing them in the live event Q&A window by clicking on the Ask a Question button. Usually the question you post will be made publicly visible, and if you prefer, you can post your question anonymously by checking the box right below where you enter it. We often get many questions during these webinars, and we are doing our best to respond to all of them in real time. If the answer was not provided or if you have additional questions afterwards, please don't hesitate to ask them on our Microsoft 365 Defender forum at aka.ms/m365dtc. If you're listening to this after the fact as a recording, you can also use that place to ask any question. We love to hear your feedback on how we can improve these webinars, so please do this on aka.ms/security webinar feedback. From us, this is really important so that we can deliver the content you need. If you haven't already, please join our community also at aka.ms/security community. And that's always the best way to ensure you don't miss any future webinars or major announcements. In our community, you can speak directly to our engineering teams that are building our security products. For Microsoft 365 Defender, you can do that also at aka.ms/m365tc. So today, I'm super excited to kick off our new webinar series, Lead Speak, Advanced Hunting with Microsoft 365 Defender, with Tali Ash and Michael Malone. And with no further ado, I will hand over to you guys.
Thank you, Heike. So welcome everybody to Lead Speak. So as Heike mentioned, my name is Mike Malone, and I'm here with Tali Ash. We're program managers from the Microsoft 365 Defender team. So Lead Speak, we're going to be talking about new capabilities and trending topics in advanced hunting. A lot of our content will actually be driven by questions that are asked inside the security community. So please contribute questions and any feedback or any thoughts. And we hope to continue these webcasts and cover the most relevant topics of the day. So today's webcast, we're going to cover a few different things. We're going to be covering some KQL performance tips. So this is something that's used in advanced hunting, as well as it's actually universally available for like Sentinel, a lot of our other products that use the Kuso query language. We're going to do a discussion on ransomware and in some ways due to detection of a ransomware. how to handle JSON and the dynamic type, as well as the external data operator. So how do we pull in information that's on a publicly accessible endpoint to bring into your queries? If you would like to follow along, we do have the query file uploaded to GitHub. So if you go to our public GitHub under webcast, you'll see a new folder called LeetSpeak with the query file for today's episode. So if you want to use sample queries later on, please feel free to grab them and try it out. If you're newer to advanced hunting, be sure to check out our recent webcast series tracking the adversary, where we're able to take you from zero to hero, all the way from the basic operators and the table structure into some very advanced techniques, including anomaly detection, pivoting, summarizing, all kinds of good information. So with that said, we're going to go ahead and start things off. Tali, let's go ahead and take it away.
Thank you very much, and hello everyone. We'll start with the performance topic. So we'll see together how you can optimize your queries so you can execute them faster and they will consume less resources. The first, most basic but important recommendation is to apply time filters. In every query you're running, please make sure to use time filters. You can do it in two ways. We'll start with the first examples. We'll look for all the logons of users from the finance department, and we would like to limit it by timestamp. So the first way is to do it through the portal. If you're querying in this editor, you have this visualized filter. Currently, it's on the last 30 days, which is the longest lookback time available, but you can change it to query for the last 7 days, and the query will run for the last 7 days. You can also use the custom range option. You can set exactly the date and time you would like to filter on, and then it will execute for this specific time. So this is one way through the visualized filter, but you're not always running the queries in the editor, in the portal. Maybe you're running the queries through the APIs, which is even more important to apply timestamp filter for. Therefore, you can do it directly from the query. You can write a condition using the where and the go operator to filter for activities in the last 10 days. And then again, we can execute. I can change it to 30 days, but it will actually run for the last 10 days as written in the query. Another option is to query for a specific time range you're interested at. Let's assume there was a specific activity or incident and you would like to see all the logons around this specific time. You can define a variable with exact date and time and use the between operator to filter for all activities that happened 2 hours before and 2 hours after this selected time. A very common scenario is where you're investigating an alert, and we look here at a specific alert of impossible travel activity. You would like to see logon activities that might be related to this specific alert. So what we will do, we will join the alert info table together with alert evidence table, two tables that gives us all information on the alert and the involved evidence, all entities in the alert. We'll join them by the alert ID, and then we'll take the user, the account object ID, which is the strong identifier of the user, and we'll join it with identity logon events to find related logon events that happened 1 hour before and after the alert time. So this is another way to use the between operator, and you generate the time from the query itself. You don't define it yourself. So this is super important. Make sure to always apply time filters in your queries. Second recommendation we have is to use has. If you're looking for strings, for a part of the strings, but for full tokens, has beats contains. So let's first understand what is the difference. What is the difference between contains and has? So in these examples, we are looking for network connection to from Microsoft Defender for endpoints from our devices to URL that contain team. And when we are filtering that, we can see different remote URLs that have a substring of team in the URL, but actually all of them, in all of them, the full token is teams and not team. So now if I will use the team, I will run it for the last 7 days, you will see that I don't have any results because has will work only for full tokens. So what we can do in this case is to filter for the full tokens and we will get the results. Another example is for Microsoft.com. If we are using contains, it will find us all URLs that contains Microsoft.com. In this case, it is a full token, so we can actually use has as well. We need to use has and not contains. This is our recommendation. Look at it. We have 50 results if we'll use has. Oh, sorry, I limited it by 50, but I can promise you it will give the same results. In addition to that, we can see that all the URLs have Microsoft without capital letters. It means that we can use case-sensitive string operators, and we always recommend you to use case-sensitive operators when it is possible. If you know exactly what you're looking for, it is better to add the CS prefix to the operator like has and run it, and we will get the same results because we don't care from a string like that at the moment. This best practice also applies for using regular equals and does not equal operator. And with this performance recommendation, we'll also answer one of the common scenarios that you were asking us of how you can get latest information on user or device. So let's start with understanding where you can find information on user or device. For this, we have two tables. The first one is identity info. It contains information about users. It is based on Azure Active Directory information. And we also have device info table, which contains information about devices coming from Microsoft Defender for endpoints. In case of devices, the devices are sending an update every 15 minutes. You will see here a new row for every device that is communicated successfully every 15 minutes, but with not a complete information. Not all the columns here will be populated. Columns like OS platform that change like once in a while, not in a very frequent basis, will get populated only once a day. So in this case, what we will do, we would like to get the latest information about Alex WPC. So we will use the equals, which is case sensitive, because we have the accurate name of the device. We'll also filter for the rows that the OS platform is populated because we want to get the complete information on the device, not partial. And we will summarize it by ARGMAX on the timestamp. It means we'll get the latest record about Alex WPC, and we can see here the complete information, the device, the timestamp that it was sent to the OS platform, and so on. We can do the same for users using the identity info table. However, in this user, we don't have timestamp field, so we should use the ingestion time field, which is the time the row was written to this table. And again, we are using ARGMAX on the ingestion time. And in this case, we will look to get the latest user information on all the users in the finance department. So we will run that, and we can see we have here 9 users, and we have the latest information for each. So this was an example of how you can get latest information on user or device, together with the recommendation to use case sensitive and not the equals with tilde, for example. If possible, case sensitive is more efficient. And now to the most interesting recommendation, which is how you can optimize the join operator. We are all using joins, but it can be very not efficient. We will need to try to reduce the dataset before joining to limit the join size. This is super important. And we will see a query before and after. In this scenario, what we would like to do to get a complete information, about emails that contains attachments. We have the email, what happened during the delivery. We want also to have the attachment information. And in this query, which is super bad, not efficient, what we are doing, we are getting all email events table. We are joining on email attachment information on network message ID. Let's run it. You can see how much time it takes. And we have results. So it took a while. And what we did here, we joined all the emails, including emails that don't have attachments at all. And this was not in my scenario. I wanted to get information only on emails that have attachments. So let's see together 2 ways that you can improve this query. So first, you always need to filter the left table, the one before the join, as much as you can. The email events table in advanced hunting is the largest one. You should never put it on the left side of a join if you don't filter it. So first thing, super simple we can do, is to filter only for emails that has attachments. So this is the first filter. Once we are doing that, we can change the kind of the join to inner in case that there will be emails that contain more than one attachment. We would like to get its information. And we also improved here the key for the join. We added recipient email address. Network message ID recognizes an email, but an email can be sent to several recipients. Therefore, we should make sure the key of the join is accurate as possible. So we also added that. And now let's run this query. You see, it is much faster than before. So this is first option. Second option is instead of using email events, which is a super large table at the left, to use email attachment info, to put the smaller table at the left and the larger table at the right. And what we are doing, we are getting email attachment info. We should still use the join of kind operator, and we are joining it with email events, but of course we keep the filter of email events to include only attachment, only emails that contains more than a single attachment. And the key is also the accurate key. And we can see it is working as well. And I didn't pay attention, but the numbers are the same. Here we get 509. And also if I will run the previous query, it should be the same. Yes, we're getting the same amount of results. So first example of how you can optimize joins. We'll look for another example which can be common, that you would like to get more information on alert. So in this example, what we are doing, we are looking for specific alerts, alert types. We are filtering them by the title, and we would like to get information about the device, the machine that was involved in the alert, and then get more information about logon activities around the time of the alert. What we are doing now, we are joining alert info without any filtering, then joining alert evidence and applying all the filters. This is bad. We should not do that. As we said earlier, you should first filter, put the smaller table at the left, or at least filter it as much as you can. So what you can see here is that we moved the filters of the alert titles right after alert info, that it will be filtered before the join. So we get much smaller table at the left. And then we are joining on alert evidence only where entity type is machine and not on the entire alert evidence table. So to summarize this part, to optimize your queries, always apply timestamp filters. If you're looking for parts of strings, use has and not contains if you're looking for full tokens. If possible, use case-sensitive operators and because it is better. And when you're running queries with joins, make sure they will be optimized. Put at the left the smaller table, filter it as much as you can, and make sure your key for the join is accurate. In the beginning here, you have a link for documentation. We have a section in the documentation, apply query best practices, that provides a lot of information you can use, and also how you can handle error and improve your queries. So this was our first topic for today, and I will give it back to you, Michael.
Awesome. Thank you, Tali. So let's talk a little bit about ransomware. So ransomware is a pretty popular topic today, and Defender, the Microsoft 365 Defender stack provides a bunch of different types of alerts for this. So what I did is I actually had to disable a bunch of features of Defender for Endpoint in order to get these tests to work without interruption. But I wanted to I ran a couple of different types of ransomware on one of my endpoints in the lab to talk about not just what ransomware is and what type of detections you might see, but also some differentiation between commodity ransomware and human operated ransomware, as well as I wanted to provide an example of a query that you could use to identify destructive activity and kind of go through some of the behaviors. So as you can see, I received 15 different alerts on this one endpoint that I ran 2 different ransomware variants on. So we have a number of different types of detections that are out there. We see Ryuk and REvil. These are going to be endpoint protection detections. So this is going to be basically like anti-malware. Suspicious file drops, anomalies, and ASEP. So ASEP, for those who might not be familiar, is auto start extensibility point. It's basically a point on your system that enables an application to launch automatically. We've got a bunch of information about suspicious files. We even see if there's ransomware behavior detected on the file system. File backups were deleted. This is going to be one of the things we're going to look for with our query. There's a bunch of different detections that we've got from just launching these 2 pieces of ransomware. So these are the kind of things you're going to want to keep your eyes out for. Also, suspicious PowerShell command line is always something to pay attention to as well. Now, there's a difference between human-operated ransomware and commodity ransomware. So commodity ransomware is a ransomware that you might get if you open the wrong attachment, and it really only goes after your one system. This differs from human-operated ransomware in that human-operated ransomware is really a determined human adversary, or a DHA attack. So in a human-operated ransomware scenario, the attacker is going to find a vulnerability in your enterprise, whether it be a public-facing web server. It could also begin with a phishing attack, some way to initially get an implant inside your environment. And the important differentiation is that in a human-operated ransomware attack, typically the attacker is going to try and attain as much administrative permission as they can and deploy ransomware to as many endpoints as they can. So what begins as a simple breach can escalate into a broad, sweeping incident. So the differentiator here is, while commodity ransomware is only going to target one machine, your cybersecurity defenses and visibility are really going to come into question with the human-operated ransomware attack. The attacker has to be able to obtain some sort of administrative permission in order to deploy to a number of systems. So how you protect those credentials, your visibility with the Microsoft 365 Defender stack, and your response to those detections is really going to be a differentiator in a human-operated ransomware scenario. So for those of you who were in our Tracking the Adversary series a couple of months ago, we talked about the ABC method. So when you're targeting something that's a human-operated ransomware attack, it's important to focus on identifying and eliminating attacker-controlled authentication. So in other words, what accounts do we identify the attacker took over? Attacker backdoors. They're typically going to install a couple different footholds inside your environment. This is going to be things like our anomaly detected in ASEP registry. If we see suspicious PowerShell command lines, these are the kind of things that may indicate that we have a piece of malware that might be human operated inside your environment. Also, specific types of malware being detected inside your environment could be what's called a reverse shell, which is like a Meterpreter or Empire or one of those, or Cobalt Strike, one of those types of backdoors. So that's the backdoor aspect. And then the C in there is going to be communication channels. So essentially, how is the attacker interfacing with the backdoor? Is the backdoor calling out to a trusted command and control channel? Is the attacker coming from a Tor node or some anonymized network and connecting into a publicly published service? It's really important to focus on the ABCs as a method of trying to target the human operated side, because the ransomware aspect ultimately is an anti-malware scenario. So by the time the ransomware is deployed in a human operated ransomware scenario, the attacker has typically obtained administrative authorization to the endpoints they want to deploy it to. So it's important to keep an eye on these type of detections early and address the ABCs when you're talking about a human operated ransomware attack. Now, on the ransomware front, the things we can do is we can look for ransomware detections, such as Ryuk, REvil, CryptoLocker. There's a bunch of different ones out there. And we can look for behaviors. So in order to help us look for suspicious activity, there's a query that's on our GitHub today that looks for a variety of different activities performed by ransomware. So I'm going to go ahead and run this. And I'm going to go through a couple of these and describe what they're doing. So the first one we have here on line 30 is looking for deletion of shadow copies. This is done so that you can't recover your files from a shadow copy. So VSSadmin delete shadows /all/quiet. In fact, you can see we're using the has operator like we just talked about previously. This is going to look for any time somebody uses the VSSadmin application to delete shadow copies. The second one we've got here is Cypher whack-w, which is going to basically wipe the free drive space on the machine. So this is so you can't undelete a file, essentially. This is a common technique done so that, once again, you can't recover the file. Our third one here is actually tampering with the system restore task for Windows. So it's scheduled tasks /change, system restore, and then disabling it. This is a method so that Windows cannot recover itself back to a previous state. Another one here is deleting the USN journal. So the USN journal basically covers changes to modifications to files and such. Last couple we've got here. So iCackles, basically this is reackling everything on the C drive here. So this is a behavior performed by some ransomware. Basically, we're going to look for the C:/drive, get everything beneath it, and then grant everybody full control. This is not an activity you should typically see in a normal enterprise. This is implying somebody's trying to basically get rid of all NTFS access control lists so that the ransomware can write any file it wants without having to encounter any sort of permissioning issue. And our last one here is kind of a twist on our first one about deleting shadow copies. So this is going to look for PowerShell where it's running some sort of a command that's calling Win32 shadow copy, and then the delete method. This is a WMI way to delete shadow copies. So as you can see, we've got a regex here that's looking for these patterns: Win32 shadow copy delete. Anytime you see that, it's probably something you want to alert on. You'll see we've got a couple different rows here. These are from the different ransomware types we launched. One of them here is our PowerShell, and you'll see this crazy encoded PowerShell command here. That's exactly what this line 36 is meant to discover. I also have this query here. If you just want to decode PowerShell commands that might be on, let's say, a box that doesn't have the AMSI features, so something maybe like a Server 2012. If it is a one-liner, there is actually a command that's in our GitHub or query is in our GitHub right now that has just this piece so that you can decode PowerShell calls that are encoded. So the next thing we're going to talk about is JSON and the dynamic types. So there's a lot of fields inside of Defender for Endpoint, which are going to be JSON encoded or maybe dynamic. So dynamic is essentially taking a JSON object and it's turning it into something that you can use dotted notation to navigate through. We're also going to be talking about how to build these objects as well. So let's say you have a lot of data that you want to summarize into a JSON object, maybe for export to your SIM or a Power BI or something else. So we're going to talk about a couple different ways to handle this. So first, we're going to take a look at some of these. So we're going to look at the device events. We're going to summarize. We're going to one row back for each action type. And then we're going to go ahead and reorder a couple columns. They're using project reorder. This just pushes these two columns to the left. So as you can see, there's a bunch of great information in device events. And a lot of the value comes from these additional fields, which are JSON formatted. So you see like total bytes copy, desired access, base address, protection mask. All these details may be relevant to one of your detections or one of your hunts. So to get them out, let's go ahead and take a look. Let's go ahead and dive into the plug and play device connected. So this is going to happen whenever you plug in a plug-and-play device to one of your Defender for Endpoint monitored devices. You can see here we've got class name, we've got class ID, device description, all kinds of good information. So to get these out, there's a couple of different options. The first thing, so we need to be able to turn this JSON into a dynamic object. And that's what this parse JSON function is going to do. So we're going to take the device events table. We're going to look for plug and play device connected events. And then we're going to add a column here. Basically, we're actually projecting a column. So it's only going to be this new column called AT dynamic that takes that field and turns it into a dynamic object. So this is no longer a JSON string. This is now something you can actually access with dotted notation. The next thing we're doing here in line 64 is we're going to use the extend operator. Now, extend is going to be adding additional columns onto your result, and we're going to be using dotted notation. So as you can see, we're referencing AT dynamic, and then I'm grabbing the class name attribute from it. And what you'll see over here to the right is we're going to have class name. Where is my where is my class name? Apologize for that. Appear to have lost my class. Rename. Let me. Oh, hang on. That's why I haven't run this one yet. There we go. Okay, I was losing my mind for a second there. So class name, as you can see, has been extracted now, and it's its own column. Same thing with class ID, and device description. So we're actually able to pull out these individual values from the JSON just by using dotted notation. So this takes a while, especially when we have as many options as you have in some of these JSON objects. So let's go ahead and use a function called BagUnpack. So same concept here. We're going to grab device events where the action type is plug and play device connected. We're going to parse it to make it a dynamic, and then we're going to call this function. So evaluate BagUnpack. Now, what BagUnpack is going to do is it's going to take every single thing in that JSON object, and it's going to make it its own column. So you can see here we've got print queue, class ID, device ID, all vendor IDs, device description, all automatically unpacked with a single command. So this saves you from having to go column by column and basically promoting each one of those from inside the JSON object to a column. So another example of working with the dynamic objects is going to be handling lists. So for example, let's take a look at some TVM, so threat and vulnerability management. One of the features we have is context. It gives you back 3 different values here. You'll see there's a signature version, there's the engine version, and then the date timestamp when it was updated. Now these are great, but we need to really be able to pull these out in order to get a better picture of what's going on. So to do that, what we can do is we can turn this into a dynamic again, and we're going to use these operators here that are going to be look for the 0th item and then the 0th item within that. Now this is the reason why we have 2 of them is if you take a look at the way this is formatted today, you'll see there's a list inside of a list. So a list in JSON is going to be a square bracket like this, like one of these guys. So having 2 of these, what we're doing is we're grabbing the 0th list. So this is going to be the outside one. And then we're going to grab the 0th item from that list, which is going to be this 1.327.1015.0. So as an example here, what we're doing is we're going to create a column using project called signature version that grabs the value of X, which is just the column name I assigned to the dynamic conversion of the context column. And we're going to grab the 0th array and the 0th element from the 0th array, list, pardon me. Same thing with engine version, except this time it's going to be 0th list and then the first element. So it's going to be grabbing this 1.17600.5. So really handy way of handling lists in JSON. Now, let's say we wanted to get our device ID back from one of our plug and play device connected. So let's go ahead. We're going to go ahead and switch and talk a bit more about BagUnpack here. Apologize, I had these in the switched up order. So before when I did the BagUnpack, you'll notice we've got, where are we at? So I used the project statement to create AT dynamic. This time we're going to use the extend statement so we can get back our information from the machine as well. Now, if you notice when I run this one, I'm going to go ahead and oh, wrong one. That's why. Sorry about that. There we go. I'm going to get back an error. So the reason I'm getting an error is if you take a look at the fields we have here, we actually already have a field called device ID. But this is not the device ID that comes back to the tables. This is the device ID that came back from the additional fields that pertain to the plug and play device connected event. Now, what we can do, so the problem we have here when we run this one is we're going to have a conflict between the device ID in the device events table and the device ID inside additional fields. Now, we need to be able to work around this and deconflict the scenario. So what we can do is we can use the second optional parameter we have here for BagUnpack. Now, by running this one, what we have is you can automatically append additional fields to the beginning of each of the column names that come back from that operation. And as we look over here to the right, we should have a bunch of columns here where we now have additional fields, class name, class ID, and once again, here's our additional fields, device ID. So this resolves the conflict scenario that we ran into before, where there was already a column called device ID. Now, another thing that's important is when you have dynamics, if you want to do things like summarizations, you're going to need to sometimes turn these back into a string. So let's go ahead and take a quick look here. So if we wanted to get a calculation and summarize, for example, the number of different devices on a given machine, we're going to need to turn these back from dynamics into something like a string or an int that could be summarized. So what we have is we've got our query here where we have the class ID, which is promoted out here from the additional fields class ID, and we're going to add the summarize operator in. So with this, what we can do is we can use summarize, and one of the cool things we can do here is we can actually make a JSON set. So there's an operator called makeSet. What makeSet is going to do is it's going to take the list of inputs that you give it. In this case, it's going to be the class IDs. So the class ID of the devices that were plugged into the machine. And it's going to deduplicate them and give you a list of the class IDs. So in this case, what we can see is for this device ID, we can see that there was 9 total plug and play events because we're grabbing the count of rows. There's 3 different plug and play devices. That's going to be this based on distinct count of class ID. Then we're going to make a set of class IDs. So this helps us so we don't have to run multiple queries to get both the counts and get all the values from within the counts. And the last thing we're going to do is we're going to figure out the last plug and play event and the device name by using ARGMAX. The reason why I use this is this helps you accommodate for any device renames or anything. So in this case, by using ARGMAX, you can guarantee you're going to deduplicate the device name. So if you hadn't been to one of our previous webcasts, ARGMAX essentially tries to maximize the value of the first value here, so the timestamp, and then give you basically the values from the columns from where this was maximized. So by doing this, what we're doing is we're saying, I want the latest row, and I want the device name from that latest row. So if there's multiple device names for a single device ID, I get the most recent one. If I put device name over here on the right, I have the potential for a duplicate if the same device ID had 2 different device names over time. So kind of a handy way of getting a report of where different devices have been plugged in inside your enterprise. Now, let's say we wanted to get into making our own custom JSON objects. So we're going to talk about a function here called pack. Now, pack is going to create a scalar value. Notice I'm using print. So for those who may not have been in the previous, the tracking the adversary webcast, a scalar is essentially a single value like a string or an integer, basically 1 column, 1 row type value. Whereas a tabular is basically a table where we have 2 dimensions, where we have multiple rows and or multiple columns. So in this case, I'm going to create a variable called x. You can see it's called x over here. And I'm going to use the function pack to make a new JSON object. And as you notice, we're going to get, it's going to be every other item passed to the pack function is going to be the key name, the value name, the key name, the value name. So in this case, we've got a key of foo, which is set to bar, and a key of wibble, which is set to wobble. So using our BagUnpack function, you can see we can actually turn this back into a table again. So kind of a handy way if you want to be able to use create JSON objects sort of ad hoc is using this pack function. But now let's say we have a bunch of stuff from your results. So like in this case, we're going to grab email events. We're going to grab 100 of them. And then we want to turn these into a JSON object, if you will. Pack all is going to be your friend here. So what pack all is going to do is it's going to take everything that comes from the previous query, and it's automatically going to take the columns and the values and turn them into JSON objects for you. So this saves you from having to pack a whole bunch of different times to pack each individual column. Pack all will turn it all into one JSON object. And you'll notice I'm using this as an extend. So we still have all of our original information. So if you still want to be able to do summarizations, pivots, or anything else, you still have the information available for you to do so. So let's go ahead and use this in practice. So I'm going to use the email events table. I'm going to get the sender from domain, the sender from address, and then I'm going to create a JSON packed element of all the details. So in this case, what we can, and the last thing is I'm going to make a list. So now there's a slight difference between make list and make set. In JSON, a set is deduplicated. In other words, you will not have any duplicate objects, whereas a list does not deduplicate. In this case, there's probably not going to be duplicates because there's too many unique attributes of an email communication, but regardless, there's no need to deduplicate it because I always want to get all the different email communications from a specific domain and from a specific address. So by using make list, save a little bit of processing time, and I can guarantee I don't have deduplication. So in this case, we're able to say, this is actually a list of all of the different email communications from this O365 MC. Now, one of the neat things is when you have one of these JSON dynamics here, you'll notice that it actually turns into a little table in the flyout, which can be kind of handy to review the individual rows. All right, and I'm going to pass it back over to Tally. We're going to talk about the external data operator. Tally?
Thank you, Michael. Let me share the screen. Okay, so let's talk about the external data operator. Another common ask we are getting is how you can use external information in your advanced hunting queries. A very popular scenario is that you're having a list of indicators that you got and you would like to use it in a query. It can contain hundreds or thousands of indicators. So what is the best way to do it? In some cases, you would like to query specific entities, but you have a big list of entities. It's not just 1, 2, 3, or 4 that you can create a list for it. So this is why you can. This is the reason for you to use the external data operator. And let's see how is it working. So using external data operator, you can insert into your query an external source. And in these examples, we will look at this external source. It's a CSV file that we published, list of indicators related to COVID-19. You can see here a list of SHA-256 of files that are malicious. And let's assume that you would like to build queries using this list. This list can also be much, much longer. And you have 2 ways to do it. Therefore, we have here 2 examples. So the first scenario, we would like to see if there was any malicious attachment that got into our organization. And what we would like to do is to use external data to filter the SHA-256 column of the email attachment information. So in this first query, we will use the external data operator as an input to our condition, to the in operator we are running in. So what we will do, we are providing the source we would like to use, its format, and we are providing 2 columns of datetime and string for that. We can actually, for this specific case, can use only this column of SHA-256. When we will run it, it will go over this external data source and find if we have any match. In this case, we don't, which is good. This is one way to do it. Another way to use external data operator is actually to build a table of it, to that it will behave like a table and we can join on that. So this is what we are doing here. In this case, we would like to find if any process has been created on a device for file matching hash on this list of indicators. So what we will do, we will set a variable of COVID indicators. We will define it using the external data operator, and we will look only on the file hash type that is SHA-256, and we will join it with device file events where action type is file created. In this case, we are taking 100. Let's try even to remove this one. And the join is based on the hash value, which is hash file value on file hash value of the left table and SHA-256 of the right table. And let's see if we get any result. In this case, we are not getting any result as well. But those are two simple examples of how you can use the external data operators in your queries. You don't need to write your queries again and again. For example, if you have a list of URL indicators, you can write one query that will use the file where you store your URL indicators, and you can always update this file. You don't need to update the query itself to include more and more URLs. And you have here two documentation that can help you. The first one is example that we publish in advanced hunting documentation and how you can ingest data from external sources, and also the documentation of external operator in Azure Monitor that provides more information also on the limit of this specific operator. And we would like to share with you, let me find it, a nice issue that we got recently in our Git that actually covers most of the topic that we went through today. A scenario where you can see a thread, what is the scenario we were asked about, and the answer is to use most of the things that we've just discussed. It includes using the external data operator, specifically here for URL, but also the dynamics tricks and tips that Michael just showed. So this is a very nice example, and you can see it in our Git. I just want to remind you that you can also find the episode of today, all the queries we ran in our Git under webcast Let's Speak folder. You have the first episode that contain all the information. I would like to make sure you are aware of our tech community of Microsoft 365 Defender. You were asking us questions here, asking for support. We built this webcast content based on it, so please continue to share your input and questions. We are looking into this feedback. So this is our discussion area. You can come to here and post anything that you would like. And I would also like to give a short heads up before we are moving to questions on what we will be covering in the next episode. So we just released to public preview a new hunting table of cloud app events that enable you to hunt across cloud application activities in Microsoft 365 Defender. Today you can see in this table all activities monitored by Microsoft Cloud App Security in Microsoft Exchange Online and Microsoft Teams. So this is a heads up of what we are going to discuss next time. We will also paste the link to this blog where you can read more about this new table and what you can do with it, including sample queries in the Q&A area. So now we can move to some queries that were raised, and we can all learn from it. So Michael, there was one question during your section on how we can how the query results can be used for further investigation using automation. Like, what you're doing next. You're finding results in the query. What is the next step?
Absolutely. So there's a bunch of options what you can do with these results. Perhaps the best way would be using the Advanced Hunting API. So there's a couple of benefits of using the Advanced Hunting API as well. The first one is if you're using the web UI, you're going to be limited to 10,000 results. Whereas if you call the API, your cap is at 100,000 results. So you have the ability to bring back more information if you so desire. That'll help you feed it into your SIM, your source solutions, or any custom automation you might have in-house. So I would recommend definitely checking out the API documentation on that one. And there's also, I believe, some good PowerShell script examples of how to hook into the Defender Advanced Hunting APIs. Another topic that we had, Tali, was talking about the external data operator and the different formats of data that are available for it. Did you want to cover briefly some of the other options around external data?
Yes, sure. So CSV was just an example. It supports more formats like TXT, JSON. You can find the information here. CSV was definitely just an example of type that is supported.
Awesome.
Another question we got related to an example we discussed in the performance section is about device info. So I just want to clarify that device info is getting updated every 15 minutes for device if the device is communicating regularly, but not in all the rows, not in all the communications. The complete information about the device is sent. It sent a complete information only once a day. Therefore, if you would like to get the complete information, we recommend you to use the condition of where is not empty OS platform as an example, and it will guarantee that you will get records that were sent with all the data that was available at the time it is populated. So this is how you can filter out the partial rows.
Awesome.
Yeah.
And so one other thing that came up, so there's a question about another external data question about whether it could be used with a threat intelligence provider. So essentially, external data can be used with anything that could be accessed over the web without providing explicit credentials. So a common example that I've used is you can, let's say you have a file like a CSV file that can be exported from your threat intel provider. If you export that out and put it in blob storage, you can use something like a SAS token to provide authentication without having to provide an explicit username and password. So that's, but in order for external data to work, you will need to be able to provide some place that the defender can reach out to over the web where all the authentication has to be inside that URL, like a SAS token, for example. All right.
Thanks, Michael. I see another question that is related to dynamic and parse JSON. You used both to dynamic and parse JSON to get the dot notation. What is the difference?
So effectively, those two can be used interchangeably for the most part. They're just, it's just which one happened to pop at the top of my head at the time I was writing the query, to be honest. But parse JSON and two dynamic is actually a cast, whereas parse JSON is a function that basically says turn this into a dynamic. But they can pretty much be used interchangeably because the only thing that I'm aware of you can turn into a dynamic is JSON. So you can effectively use those back and forth, whichever one you prefer.
Thank you.
Right.
So with that, I think we can move to our closure.
Wonderful. Thank you, Tali and Michael. I love this webinar and I'm really excited about the next one. So before we are ending the call, just a couple of reminders. So our next schedule is up on aka.ms/security webinars. We have on November the 30th, Azure Security Center, Azure Defender for SQL Anywhere. December 7, we have Azure Security Center again with investigating Azure Security Center alerts using Azure Sentinel. December 9th, we have actually the Microsoft Digital Defense Report, very interesting topic. And then there's many more for January scheduled already, so please have a look. And again, for details and registration, go to aka.ms/security webinars. I will post those links shortly into the chat window. So if we missed any answer or any questions, or if you have additional questions, you can bring all these up in the Microsoft 365 Defender forum at aka.ms/m365dtc. Again, thank you, Talia and Michael, for delivering today's session. Thank you to the rest of the team who helped answer all the many questions that came in. And also for everyone who attended, thank you very much for being part of our community. And with that, I hope to see you next time again, and have a good rest of your day or evening or wherever you are.